Hello. You should hear me and you should see the desktop by now. Is everything okay?
Yep, it's looking good.
Okay, great. Thanks. Wait, let me pop up a couple windows that I need. All right. Okay. All right. So I'm going to talk some more about ML today. Uh, I gave you a reading assignment for the read the chapter about types in the book. I'm not going to spend not going to go over what's in that chapter specifically. It's an interesting chapter to read. What I want to do instead is just keep talking about ML and talk about how ML uses types. And the reason is that anything you can say about types in general is going to be false for some language. Types are very hard to talk about in a general way. So in this chapter on types, if you look in the book, sometimes they talk about C, sometimes they talk about Java, sometimes they talk about languages you haven't seen in a lot. Like here, they talk about C, Java, ML. They also give examples in a couple places, like here's Scheme. They mention I remember in the book they talk about Pascal and Ada. So when you talk about types in general, it's real hard to say anything that's true all the time. For example, the most important thing they say in the chapter is this: a type is a set. That's real important. It's also not true. It's not always true. It's true enough of the time that it's real important to say that. For example, what does it mean to say int x? You're specifying the set of values that an int can hold. Okay. Now, like in Java, that's one set of values. In C, it's a different set of values. Well, it depends on whether you're using 32-bit C or 64-bit C. But it's important to say that, yeah, for the most part, a type specifies what values that variable can hold. When you say that n is an int, you're saying what it can hold. So if you say n is a double, it holds different values than if it's an int. Okay. Now, that's not entirely true. For example, in Java, there are interface types, and interface types aren't a set. Okay. Interface types are kind of hard to pin down in general, but in the Java language, an interface is a type and it's not a set. Okay. Okay. So it's very hard to talk about types in general. So it's more useful to talk about types in the case of every particular language. What does type mean in Java? What does type mean in C? What does type mean in ML? And then sort of compare them. Like type in ML is not the same as type in Java. So we're going to learn how ML does types. And over time, we'll compare them. We'll compare how ML is different than Java or C. But a chapter like this that tries to talk about types in general, I've read these chapters in many books, and they're interesting and they're useful to read, but you have to take everything you read with a little bit of grain of salt because every time they make a statement like this, yeah, it's actually not true. A type is a set most of the time. And it's probably, I think in ML, it might actually be true that a type is a set all the time in ML, but it's not true in all languages. Like I say, a counterexample is the interface type in C and also in C++. In object-oriented languages in general, the interface type is not really a set. It's more complicated than that. Okay, so read chapter 6, and there's some interesting examples in there, and it but we're gonna do is today is we're gonna go to ML and go back and look at some more examples of functions in ML and see how types enter in defining functions. And then there's also a reading assignment for you to look at the second chapter on ML. So there's a reading assignment for you to read the a beginning of the second chapter on ML, which is chapter 7 in the book. It's the second look in ML. Okay. Now, let's just look at some example code in ML. I've got some example files here to look at. Okay, so I what I'm going to do is I'm going to open them in an editor, and then I can load them into the ML interpreter. So here's a file. Okay, okay. Here's one file with some simple examples. Okay, so I'm defining a function f1, f2, f3, f4, f5, and f6. Okay, okay. And I really want to kind of look at how they use types. Okay, so f1 takes in x and y and adds them. F2 takes in x and y and adds them. F1 and F2 are not the same function because they take in different types. Okay, F1 officially takes in one tuple. Okay, F1 is not a function of two parameters. F1 is a function of one parameter. That parameter is a tuple. That's the ML notation for two things bundled together in a tuple. So if I start up over here, just the interpreter, uh, I can say val x equals the tuple 4, 5. Okay, x is a variable whose value is the pair of things 4 and 5. Okay, now x is one value. X is one variable with one value. Okay, now that a tuple can be a mixture of things. Like I can say val y equals a tuple of cat and 6. So notice that val had the type int times int. Now you read that not as multiplication. That's a type description there. In ML, star means multiplication in some situations, but when it comes after a colon, it's a type declaration. And it's saying that the value parentheses 4, comma 5, close parentheses, that value has type integer paired with integer. If you want, you could read that integer times integer, and that's how people read it, but don't until you're real used to it. This is not the multiplication symbol. This is the pairing symbol. It's saying the type is integer paired with integer. This guy has the type, this value has the type string paired with integer. Okay, so that's its type. Its type is string paired with integer. Okay, now that's one value. Okay, now this function over here, f1, when we define it, it takes in a value that is two integers paired together, and it takes the integers in that pair and adds them up. Okay, this function takes in two things. It takes in an integer and an integer. Okay, now notice I didn't say it takes in integers. That's getting into ML's type inference. ML sees that you're taking in two things here. Then it looks over here and says, what do you do with them? You add them. Well, what can be added in ML? Well, you can add two integers or you could add two reals. It doesn't know whether there's not enough information here to say that this is a real or an int. So it just makes the choice for you, and it says it's an int. When ML can't decide if something should be an int or a real, it makes it an int. It knows it's not two strings because in ML, you don't concatenate strings with a plus. For example, if I turn that into this, now that function takes in two strings. Not because I changed anything over here. ML says, well, it takes in two things. What do you do with the two things? You apply the concatenation operator to them. The only things that can be concatenated are in a string and string. So now F2 is a function of two strings. If I put this here, now F1 is a function of a pair of strings. Okay, it's a function of a pair of strings. Okay, so this is a pair of ints, but that's a little bit ambiguous because you can add two reals, but ML says, well, you could add two reals or you could add two ints. I don't know which one to use here, so I'm going to make them ints. Same here. This takes in a pair of ints, this takes in two ints, and they're ints because, well, you look at here and you say you're adding. Adding could be adding to reals, or it could be adding to ints. It can't tell which one to use, so it defaults to being adding to ints. Now over here, I actually declare here. Now I'm doing things more like Java would. I'm saying f takes in, well, it's a pair, so it only takes in one thing. F3 doesn't take in 2 parameters. F3 takes in 1 parameter because of the way the ML type system works. It's a pair, the pair, because there's a parentheses declare pairs. Okay. ML language, we say that's a constructor of pairs. So I'm constructing a pair as the input. X is the first thing in the input pair. And here I say, oh, it's a real. Okay. So over here, when ML says I'm adding, it just verifies that that reals can be added. Here I'm saying that X is a real, Y is a real, and over here it says, well, you're adding. Can I add reals? Yes. For example, if I do this, now I'm in real trouble. I've said that X is a real, and I've said that Y is a real. ML looks over here and says, you're concatenating. Can you concatenate a real with a real? In some languages you can, because in some languages, this will be converted to a string. This will be converted to a string, and then the strings will be concatenated. Some languages like JavaScript would do that for you. ML says, no, I only concatenate strings. You've declared these things to be reals. This thing will not compile. That'll be a compiler error. Remember, if I did it over here, that'll compile because ML says, you didn't tell me what the types are here, so I will figure them out for myself. ML looks at this and says, you're concatenating, so this guy's a string and this guy's a string. Okay. And ML then decides that this is a function of a pair of strings. Okay. And now it's a pair of ints. Over here, ML says, you're telling me that it's a pair of reals, but then you're trying to concatenate them and it won't compile it. Okay. And if you do this, then ML says, you're telling me it's a pair of reals, and it's okay to add reals, so this compiles. Okay. Notice the difference in logic over here. This one checks that it's okay to add reals. This one says, I don't know what the type of XY is. So it looks and says, internally it looks and says, plus can add 2 things. It can add a pair, it can add 2 ints or 2 reals. I don't know which one to use. I'm going to default to 2 ints. So then it goes back over here it goes backwards from here to here and says, this is a pair of ints. Okay. Now over here, look at this one. F4 takes in one thing, a pair of things. It takes in one thing that is a pair of things. I don't say what Y is, but I do say that X is a real. Okay, so ML says, okay. Now it looks over here and says adding. Well, adding can add 2 ints or add 2 reals, but X is a real. So now this is adding 2 reals. But if it's adding 2 reals, Y is a real. Okay, so ML infers that this is a pair of reals. From that piece there and that thing there, it decides that's a pair of reals. And again, if you do that, won't compile. Now the reasoning is, you're telling ML X is a real. ML doesn't know what Y is, so it has to figure it out. It says here you're concatenating. Okay, Y is a string. You concatenate strings. Y is a string. Wait a minute. X is said to be a real. You can't concatenate a real. So stop compiling. See, now there's an error. Y is a string because it's on the right-hand side of concatenation. X is declared real. You can't concatenate a real, so won't compile. Notice there's a mixture here of declaration and inference. Y is not declared. It's inferred to be a string. That's okay. But X is declared a real. That doesn't go along with the type of concatenation. Okay. Now, if I put that back to plus, now ML's type system says, okay, you told me X is a real. So I go with, if you say something in your code, ML goes with that. You said X is a real. So ML is going to take that. You didn't say what y is. So ML has to figure out what y is. It goes here and says plus. Plus can be 2 reals or 2 ints. I still don't know what y should be. But x is declared real, so I'll go with that. So that's the addition of 2 reals that forces y to be real. So F4 takes in a pair of reals. Okay?
So is there any difference of F3 and F4 then?
No, they're just only in the way I wrote them. Yeah, you're right. That's a good point. F3 and F4 are the same function. I mean, it's 2 names for the same function. Okay, so F3. So most ML programmers would probably write it as F4. They wouldn't write, or it's kind of ML programmers would probably write it as F3. I'm sorry, as F4, because they would give the minimal amount of notations to mean I want to add 2 reals. And some ML programmers would write it this way, saying it's, just to be more clear. Okay. And if they mean this, they won't put any type of, no, this thing is the same thing as saying int. Okay. Saying I haven't changed the function, but ML programmers usually wouldn't type that. Though people argue about these things. ML doesn't require type declarations, though sometimes, well, actually, here it's required, because without the type declarations, this guy would be adding 2 ints. So either 2 declarations here or 1 declaration here is required to make this adding 2 reals. To make these functions a function of real, some declaration is required. Okay. Here, the declaration wasn't required to make this the addition of 2 ints, and it's up to the ML programmer to leave it with no declaration of type or to put the declaration. And again, then you could just say, you could do that. That'll be fine. Now that doesn't change the function. You can do this. That doesn't change the function. Okay. All right. Oh, and same here. You can do that. Or you can do that. Now, if you do that, you have to put parentheses around here to group that. You do have to put parentheses there. That's kind of, the notation gets a little bit touchy here. Here I'm saying that x is a real, so then this becomes the sum of 2 reals. If I just did that, my grouping is going to be wrong, and I'll get a weird error message. Okay, it does ML, the order of operations here is a little bit messed up, and I want to say that this is the type of x, but the order of operations won't work quite well. So then I have to group the declaration. Okay, that's something you never do in Java. You never group declarations, but in ML you do. So if I wanted to say that F2 takes in 2 things, an x, which is real, and a y, which I haven't said what it is, and then it's supposed to add those 2 things. Again, ML is going to look at this and say, adding can be 2 reals or 2 ints, but you told me that x is a real, so that means this is adding 2 reals, so that means this is a real, so it goes back and says that that one's a real. Okay, so then that would be the same function as if I then went added this to it. Okay, but without the type annotations, ML sticks to its default of adding 2 ints. Okay.
I have a question.
Mm-hmm.
You may have covered this before. Can you cast, like if you have x colon real, could you like cast y to a real, like if you're taking in a parameter?
Yes. Okay. Suppose I'll do it down here. I'll make an F7. Do I have 7? Okay, I'll make it F7. Okay. Suppose I want F7 to take in x, which is a real, and y, which is an int. I want to kind of force one of them to be real and one of them to be int. Okay, I've got to group the types. I mean, I wouldn't do that in Java, but I've got to group these types. Okay. Now, I cannot say x plus y. Why not?
It just doesn't work in ML?
Yeah, because plus takes what?
Is it only like it's only 2 reals or only 2 ints?
Yeah, exactly. It's really It's really adamant about that. 2 reals or 2 ints. And ML doesn't cast it. In Java, when you do 1 plus 2.0, what's the answer?
3.0.
Okay. What do we call what happens to 1? There's a name for it. You do not add 1 to 2.0. Java doesn't do that.
So is it just sort of casting behind the scenes?
Yes, but it's not called casting here. It's got a different name.
Yeah, I don't remember the name. I know what you're talking about.
Promotion.
Okay.
Yeah, 1 is promoted to 1.0, which is a promotion and casting are similar ideas. So you could say that this is casting. So you could say that Java does that. It casts 1 to a double behind your back. Okay. We usually use the word it promotes 1 to a double behind your back. Okay. ML will never cast or promote anything. Never. Okay. Similarly, in Java, I can do this. Okay. The 1 is converted to a string. Now, that's not even a cast or a promotion. That's just a conversion. 1 gets what actually happens. Does anybody know what really happens there? This is concatenation of strings. So this needs to be converted to a string. You call the toString method in the integer class. You actually, what happens is toString. This thing, you call the toString method to convert that thing to a string. So it's neither a cast nor a promotion. It's actually something a little bit more subtle. It's calling the toString method.
Is it boxing?
Well, it has to box it first. That's not, so it does 2 things. It boxes it and then calls toString. So it boxes the 1 as an integer and then calls toString on the integer. So, but it's not promotion and it's not casting. It's boxing and toString. Okay. ML never does these things behind your back. Okay. So we go back up here to the ML one. What do I do here? This won't compile. That's a real, that's an int. Okay. So there's a function. Now it's not a cast, it's a function. There's a function called real that converts ints to real. Now that's not a cast, it's a built-in function. Okay, I go over here. Real of 6 is 6.0. See, it's not a cast, it's a function. It's like toString. Yeah, it's a function that takes in an int and gives. Now, okay, now look, I can't see if it was a cast, casting a double to a double. Oh, that's fine. In Java, you're not going to get an error message if you take double and cast it. If you cast a double to a double, some compilers will warn you and say redundant cast. You'll get, if you do that in Java, the compiler will probably give you a warning that you have a redundant cast. The C compiler does the same. It gives you a warning, just like a friendly warning that that's redundant, but there's no error there. Okay, Now, real is not a cast in ML. Real is a function, and that function takes in the type int. So this doesn't make sense to ML. Okay, real. See, real is see here, if I ask ML, what is real? Real is a function from int to real. Notice that the word real is overloaded. Real is a function and real is a type. Java's like that too. There's lots of overloaded words in the Java language. So here they took the word real and overloaded it. Real is a function from int to type real. Now you know that's the type real because it's in a type annotation. See, function has type. Well, real has type function of function type int to int. This is actually a little bit redundant. This part here is redundant. real has type function. But ML kind of is verbose here. It's saying that real has type function, and the function is a function from int to real. For example, there's a more modern version of ML called Haskell, and when in Haskell they don't put this little thing here because it's redundant. Real has function type. There's the thing that says function type, int to real. So this part here is redundant. It's saying this is a function, and it's a function from int to real. So yeah. So they're saying that real is a function, and the kind of function is from int to real. Okay. All right. So over here now, there's my function. Oh, this should have been F7. Okay. There's my function. It takes in a real and an int and adds them together. So, and then the result's going to be a real. Okay. So I can force the issue that f takes in a real and an int and gives me back then I can, what you might think of as I don't need the in this case I don't need the parentheses since there's nothing after that. So it's x plus the real of y. Okay. All right. So ML, now remember, plus only does two ints or two reals. So if you just do something like that, these guys have to be the same. Okay, they have to be the same. So that's either two ints or two reals. And by default, if you don't say otherwise, it's two ints. Okay. If you declare one of them, then that forces the issue on the other one. If you declare both of them and you make them different, then you've got to convert one of them to real to make, there is no downcasting here. I cannot convert the real to an int. Well, I can. Yeah. Let's do it. Let's do that one. It's not a cast, it's a function. The trouble is there's multiple ways to turn an int. I'm sorry. There's multiple ways to turn a real into an int. Okay. Start telling me, like, what's one way to turn a real into an int?
Would you just round up or down, or?
Okay, that's one of them is rounding. So ML has a round function. I think it's called round. Okay. Now we have to put parentheses here. You could round it up or down. Okay. But what else can you do? What's another thing you can do to a real to get it into an int?
Doesn't Java just like drop everything after the decimal?
Yeah, it just drops whatever's after the decimal. That's what Java does when you cast a real to an int. It just drops things. That's called truncating. If I remember right, in ML, it's the trunc function. You truncate x. Okay, let's see. Let's load these into M. Now this is my function is called example2. It's in this folder. Over here, if I want, I could be fancy. I can say use. Now the folder is called 2021 02. It's on my desktop, and my shortcut's on my desktop. So ML is operating from the desktop right now. So I have to say folder name, then example2.sml. What did I type wrong? Does anybody remember what I did wrong here? You're gonna make these mistakes yourself. So it's kind of good to What mistake did I make?
Is it you
Oh
need
no.
a backslash or?
Oh, I thought no. Okay, I did. I used the Linux slash. I used the right slash. Yeah, I did use the right slash. Did I misspell something? Oh, I misspelled it. It's example underscore 2. Yeah. Remember, I could use either the Linux slash or the Windows slash, but if I use the Windows slash, I have to escape it. And the mistake was I forgot the underscore in my variable name. Okay. I forgot the variable name. Okay. So my program, look, now I did get some compiler messages. So I actually didn't type the code real carefully. So let's try to. I got a lot of compiler errors. I thought let's see.
You didn't put font in front of F7, F8, or F9.
Oh, yeah, yeah. I I keep forgetting that you have to declare them. Okay, that makes a big difference. Yeah, especially if when you go play around with languages like JavaScript, you don't have to always declare these things. So okay, so I needed to say that these are function declarations. Okay, so let's see if that fixes things. Okay, so save it over here, reload it over here. Okay, there. That was the mistake. Notice how you got gazillions of errors. This is it's a lot like C++. ML shares with C++ really lousy compiler error messages. It kind of shares that with C++. You can get pages of error messages from like one misplaced comma. It literally, and you can just misplace some simple little thing and get pages of error messages. Okay, so now let's look at our types. ML tells us the types of everything we declared. Okay, F9 takes a real int and gives us back an int. F8 takes a real int and gives us back an int. But this one rounded the double to an int, and this one truncated the double to an int, the real. Okay, so there's ML has no notion of casting. There's these functions that convert from one type to another, and you have to tell it what function to call. So here I said, I want to convert my real into an int, okay? And I want it to be truncated. Or here I want it to be rounded, here I want it to be truncated. So for example, F8 takes in a pair. The first part should be a double. And the second part is an int. Okay. Oh, did I type that wrong? What did I do wrong here now? Oh, I'm sorry. I got mixed up with my parentheses. The F8 doesn't take in a see, I saw that and I thought I was doing a pair. The ML, you have to really get used to reading the language. See, what mistake did I make? I glanced over at the other side and I saw F8 takes in parentheses and I thought pair. But that parentheses is grouping to that thing. And that's not a pair. That's two numbers. See, it's more like F2 than F1. Here, the parentheses is pair because of the comma. Here, the parentheses was grouping to say that the real is attached to the X. So that was a grouping parentheses. Like any other programming language, lots of symbols are overloaded. So the parentheses means pair, but the parentheses also means grouping. Here was grouping. So over here, I was supposed to do two numbers. See, F8 just takes in two numbers. Oh, and when it's two numbers, there's no comma between them. Yeah, when it's two numbers, there's no comma between them. It's not Java. Okay, so it's just two numbers. Okay, there. All right. So F8 takes in the 3.6 and the 1. Okay, and F8 rounds the 3.6 to 4, adds 1, and gives me 5. Okay, now on the other hand, F9 is going to take the 3.6 and truncate it to 3 and add 1 and give me 4. See, so they don't give me the same result. One gives me 5 and one gives me 4. Okay, so if you write your own type annotations, you can get these functions to do pretty much anything you want. There's no automatic casting of any sort anywhere. You have to tell ML how to convert things, and you do it by functions. There's a round function, a truncate function, a real function. Okay.
I have another question.
Uh-huh.
So for F7 through F9, can you also write it as sort of like F3 or F4 rather? Like, could you write it like F4 and then?
Okay, what we I mean that these took in a tuple? Is that what you meant?
Oh, that's a tuple. Okay, I was just confused. Okay.
Yeah, this parentheses is tuple. This parentheses is grouping. Boy, is it, yeah, it's tough to read. It's welcome to programming languages. You're used to Java, and you may have forgotten how quirky it was when you first learned Java. Now you're learning a new programming language, and you got to get used to these things. That is tuple. That is grouping. Okay,
so F1, F3, F4 are all tuples. F2 is two individual ints or reals.
Now let's turn this one into a tuple. So let's take F7, and I'll call it now F10. Okay, what do I do to make it a tuple?
It would just be x:real, comma, y:, and parentheses.
X:real, okay, comma.
And then delete that parenthesis.
Yeah, I don't need the grouping because the comma does this separating for me. So now I don't need this. Now can be tuple. Now I can group it still. If I want it, if I can put a redundant extra parentheses like that, and I can put a redundant pair of extra parentheses like that, but I don't need the grouping there. The comma separated things for me. Okay, so I'll write it the minimal way. Okay, now my F10 takes in a pair of things. The first thing in the pair is a real. The second thing in the pair is an int. And then it adds them together by taking the real and converting the int to a real, and adding them and giving the result a real. So I've taken F7 and converted it to something that takes in a pair. Okay.
When you say a pair, it's still a tuple, right?
Parent, yeah. Tuple, the word tuple, that's a tuple that's a pair. That's a tuple that's a triple. That's a tuple that you could say is a quadruple, but nobody really does that. That's just called a tuple with 4 things in it. So a pair is a tuple of 2 things. A triple is a tuple of 3 things. And this is a tuple. Okay, like we still call this one, that's a tuple. It's a tuple of what? 1, 2, 3, 4. Oh, well, it's not a tuple until I put a comma there. So tuple means this putting things together in a not a list. These things are tuples. So it's a data type that Java simply doesn't have. You've not seen C, C++, Java, Python. No, Python has tuples. Java, C, C++, and JavaScript don't have tuples. Python, I'm pretty sure, does have them. Okay, So that's a tuple, that's a tuple, that's a tuple, that's a tuple. But that tuple we can call it a pair. Yeah, and that tuple we can call it a triple. Some people might call that tuple a quadruple. Okay, but it's so tuple means I'm using this product type. Okay, if I take these, like if I take this one and go over here and I put it into ML, CML tells me it's a tuple. It was a tuple of int, 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 int. Tuples can have mixed type. There's a tuple of int, 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 real int, int, int. Okay. It's we call this a product type. Another word for tuple is product type. So this is a tuple, it's a product. This is a tuple, it's a product. That's why it uses the multiplication symbol over here. We'll say later why we call it a product. Okay. Well, later on we'll say why we call it a product and why ML uses the multiplication symbol to mean tuples. Okay. So pair is a tuple of two things. Triple is a tuple of three things. Okay. Now let me reload the function, the file. Okay. F10 takes in a tuple now. See, it takes in one thing. So F10 if I want to call F10, I have to take these things and put them in a tuple. So I need to put the parentheses there, the comma there, the parentheses there. Now see, F10 took in a real and an int. So there's the real and there's the int in a tuple. And it gives me back 4.6. Okay. Right. So I can pretty much do anything I want if I'm willing to write a little bit of code. Okay. So, from this, which just takes two ints and adds them, I can get all kinds of variations on this. And I can get it as input being tuples and input being individual items. So this function officially takes in only one thing. That one thing is a tuple. This function officially takes in two things. One of them is an int and the other one is an int. If I want, suppose I want to write a version of, okay, I'm going to do F11. I wanted to add three things. How many ways can I write this function that adds three things? Notice I got two ways up here. Start reeling them off for me. How many ways can I get it so that I'm gonna say fun F11, F12. There's a bunch of different ways. See how many we can come up with. F13, 14, 15. I'm not sure if we'll get this far. Okay. What does F11 take in?
3 ints.
Well, okay, if let's fill out the right-hand side. X plus Y plus Z. Now it's 3 ints. Because if I just do that and I ask you what is okay, suppose I just do this. So I don't have a right-hand side. And I ask you, what does F11 take in? What's the most you can tell me?
Ints or doubles?
No. You know nothing about the right-hand side. So it takes in what? Something called X, something called Y, something called Z. So what can you tell me so far? It takes in what?
Three variables.
Three things. Three things. Okay. And then if I finish it like this, now I can deduce that there are 3 ints. Okay. But what's another way to say the function takes in 3 things? Remember up here, there was two ways of saying two things individually and two things bundled in a pair. How many other ways can I get this? How many other ways can I? So let's do it this. Let's think of it this way. There's the three things.
Could you have two of them in a tuple and then one of them individually?
Yeah. Okay. So we'll make it. Every one of these guys is going to take the three. There's going to be, in a sense, three things. Now here, what could I do? I could take two of them. Right? How else can I do this? What else can I do?
Just different combinations of that. You could do the other two as a tuple, or you could do all three as a tuple.
Right. So I can do X by itself and the Y, Z as a tuple. Okay. What else can I do?
X, Y, Z as a tuple.
Yeah, X, Y, Z is a triple. A tuple that's a triple. Do I have any others?
I guess X and Z as a tuple.
But then I'd have to change their order. Because I can't get this guy and this guy in a tuple with something in between them. So this would be three inputs individually. This is two inputs where one of the inputs is a tuple. This is two inputs where one of the inputs is a tuple. And this is one input where the thing is a triple. Do I have any other choices? Is there any other way I can get three things, X, Y, and Z?
Each one of them in their own tuple.
Oh, there is no, oh, that's a good point. There is no tuple of one. There is no tuple of one. Okay, let's go over here and just check that. There's a tuple of two. Let's try to make it a tuple of one. Okay, notice the type. What is the type?
Just an integer.
Yeah, it's not a tuple of one, it's an int. Okay. What's the parentheses mean here?
Tuple.
Tuple.
Two.
Tuple. What do you think the parentheses means here?
Order of operations.
Yes, grouping. It's actually grouping. It's just saying group one by itself. Okay, so it's not build a one tuple, it's grouping. Remember, we saw that over here. Some of these parentheses were tuples and some of these parentheses were grouping. See, like, okay, this guy was what? The left parentheses in F3 did what?
Made it a tuple.
Yeah, and you have to scan over to find out, and you see the comma means tuple. On the other hand, that was grouping. You scan over, there's no comma. See, there's the closing, and you never saw a comma. So that means this guy's grouping because you never saw a comma. So that was grouping. Here, what we have now is that's grouping, that's tuple. Grouping, tuple. So there is no such thing as a tuple of one. So if I went over here and did what have I done? It's syntactically correct, but what have I done?
You just made them just like F11.
Yeah, it's just F11 over again. It's just, I just grouped X by itself. I grouped Y by itself. Now this would be useful if I wanted to now say X is a real. See, the grouping can be useful for now saying, well, I need to group a type in there. So that now the parentheses are grouping, and now I'm saying X is a real. What does that do now?
It forces Y and Z to be reals.
Yeah, it forces all of them to be real at this point. Okay, so the grouping can be useful. So the grouping here would be now, because if I drop the grouping, that won't compile. That'll give me a weird compiler error. I need the grouping to be able to type that. I didn't need grouping to type this because the comma did the grouping for me. The comma has the subtle effect of saying, here's what the order of operations are. So the comma ties this guy to the X. But without a comma here, there's nothing, this gets misread. This gets misread. Okay. Now, I got a compiler error message at line 33. If I go over here, line 33 is the one I said isn't going to work. See, so the compiler error message was at line 33. Good luck reading the compiler error message. Okay. But the problem was I needed to group that guy. Okay. The problem was I need ML. I put it on a par with C++. It's not friendly when it comes to compile error messages. That is your friend. What line number the error was on. Actually, even that, it's not always your best friend. C++ is notorious for giving you the wrong line number. You make a mistake on line 17, but it's line 18 or line 19, or even if the mistake's on line 17, it could be line 16 that the compiler error message shows up in. Or it could be
is the .16 part meaningful? Is it like the character?
Yes, that means 16 characters over. So line 33, 16th character. And sometimes the character number can actually help you. Sometimes, like here, I would start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh, it didn't like that parentheses. That's a little bit of a hint that it's a grouping problem. See, the error came up when it saw the left parentheses and said something's kind of wrong with grouping. Okay, so the line number is helpful, and sometimes the actual character can be real informative. Sometimes that can actually give you a clue as to see exactly where in the line. Some compilers give you nice error messages where they draw a little up arrow at the place where the character is that give you the error. ML doesn't do that, so it tells you line number and character number. Okay. All right. So I needed to group that. Okay. Save it. Reload it. Whoop, now what did I do wrong? Line 22. Did I go back and check? Let's see. Oh, see how I'm mixing up declarations with values? Get rid of these. Reload it. No problem. Put these back. Reload it. Problem. Problems on line 22. Notice I've never put semicolons on these guys. Okay. If you have a bunch of declarations and nothing but declarations, you don't need semicolon. But as soon as you switch to values, now I need a semicolon there, and actually I need semicolon there, there, and there. Okay. And I don't think I need semicolons here because I'm back to declarations. Okay, now let's check. Okay, go back and reload. Okay, see, fine. The last declaration needs a semicolon. Then every value needs a semicolon. And then the declarations, I go back to them, they don't really need semicolons. Now, many programmers, I probably should get in the habit of this, just put semicolons at the end of every declaration. Okay, which is probably a good idea. That's probably a good habit. Just put the semicolon at the end of every declaration. But a sequence of declarations don't technically need semicolons until you get to the last declaration. Then you need a semicolon before you, or when you get to the last declaration, then you need a semicolon to separate it from the expressions and values. And each one of these needs a semicolon. Every one of them needs one. So you get, yeah. So I think I should get in the habit of, I think it's better style for me to put a semicolon after every one of these, even though they're not absolutely required. You're less likely to get a problem when you introduce a new piece of code in there. See, if I put something in here to say, like if I say F4 of 6, 7, okay. Now, if I didn't have the semicolons, I'd have an error now. See, now I would have an error because I switched from a declaration to a function, and now this guy needs a semicolon after it, okay? Oh, let's see. Probably need maybe another semicolon. Oh, no, X is a real. So this is supposed to be 6.0. I forgot to type. X is real, so this one needs a 6.0. So that was a type error. Oh, still mistake. Line 13. Oh, I'm sorry. Again, this one forces that one to be real. So that was 7.0. That needs to be 2 reals. Because this one, when this one was real, because of what happened over here, that forced this one to be real. So I needed a real for both of the inputs to F4. Okay, so now, okay. But if I forgot that semicolon there, see, now I got an error. But the error is the missing of that semicolon. But see, now I stuck a test in there. I declared my function and I stuck a test in there, but the test now broke because, yeah. So the better solution is to put semicolons after all these. Yeah, I think I should stop being, I was trying to be minimal in typing the least amount of stuff I needed to type, but that's actually usually not a good idea. Being as minimal as possible is quite often not a good idea. So it's better to put a semicolon after every. It's like in Java when you write code like if x equal y system dot out dot println. Okay. All right. That's minimal. I didn't type the parentheses, the braces like I need to. That's fine. You're better off not being minimal and put the braces in there. Yeah, you're better off not being minimal. It's just not good. It's actually in the long run, not especially good style to be absolutely as minimal as possible. Okay. And then there's people who argue about this stuff. There are people who do like it, sometimes who do like you to be minimal, is type as little as possible. Though pretty much everyone agrees here you should put the braces. Even if you have only one line here, put the braces. And I think here in ML, I would say I'd be better off saying that even though I'm doing a bunch of function declarations in a row, I should put semicolons after each one, even though they're not required, just so that if I stick this in the middle there, it's not all of a sudden broken. Sticking this in here didn't all of a sudden break things because I didn't have the semicolons. Okay. All right. Now let's look at some. Let's look at. Let's see. I think we did. Let's look at example 3. Now example 3 is real similar to what we've just been doing. Okay. Example 3 was actually meant to show you that how you can like force the issue on one variable, which pushes it on the other. Here I'm using multiplication instead of times. So these examples here are redundant. Actually, all this up here is redundant with what we just did over here. So we already did these examples here. So that, as we were playing around with this, we did the idea of taking these two and playing around with them. Declare variables selectively and how that affects things. So over here, two inputs multiplied. Multiplication can be two ints or two doubles, or two real. I should, in ML, we don't say double, we say real. Two ints or two reals. Since nothing has been said here, then they're two ints. Here, this could be two ints or two reals, but here, this is grouping. This is grouping, and it's saying that X is a real. Since X is a real, this must be two reals, so that means Y is a real. Okay? Now, here's a little extra notation. This guy is specifying the return type of the function. Remember, in Java, we say int f, int x, int y, code, okay? The type of that input parameter, the type of that input parameter, and the return type. So for example, what does that do in Java?
Is it just gonna convert them to a double?
Well, be way more precise than that.
Is it gonna convert the result of x plus y to a double?
Okay, so what addition is this? This is the addition of what?
Two ints?
Two ints. So the result is int, but the return type is double. So after the addition is done, the int is converted to a double automatically for you by that return type. That's kind of weird. That's actually integer addition followed by a conversion to type double, a promotion to type double. So we have the type of the ints and the type of the input and the type of the output. In ML, if I really want to, I can specify the output type. It's done by saying the function f of x3, so f3 takes in an x and takes in a y, that's two inputs. Then I have to use some grouping to say that then the output is a real. Now, what ML does now is it goes over here and says this can be the sum of two ints or the sum of the product of two ints or the product of two reals. But the result has to be a real. So that means that this has to be the product of two reals. That means that this is a real and this is a real. Okay, so it has the same. So F3 is just like F2. The inputs, it's function from two reals to a real. Okay, but I'm typing the output. People don't do this very much in ML. You don't see this notation too often, but you, just like in Java, you can specify the type, the return type. So here I'm specifying the return type. Now, if I do something weird, like if I say int here, now everything's all messed up. Okay, unless I do okay, now I got a kind of a, now this makes sense. F takes in an int and something else. I have to figure out what that thing is, and it returns a real. Okay, takes in an int and returns a real. And I don't know what this guy is yet. Product of two ints or product of two reals. Okay, well, this guy is a real because it took something and made it into a real. So that is a product of a real. So that means it has to be two reals. So Y must be a real, and that agrees with this return type. And this has to be an int because I convert ints to real, and this is an int. So this thing all matches up. Okay, it all matches. It takes in an int and a real and produces a real. Okay, so I can type it that way if I want. You know, so I can specify the return type. If I did this, it would still be okay. Why? Why is that okay? Does ML have enough information to process that line of code? I deleted the return type. What is the return type? See, let's read along. X is an int. So ML agrees with whatever you specify. Okay. Y, don't know. X is an int, and you can convert an int to a real. Okay, so that's a real. But if that's a real, that means this thing is a product of two reals. So that guy has to be a real, and the return type is real. So that means that this thing was actually redundant. On the other hand, if I get rid of that, now that's not redundant. Well, and then let me get rid of this over here. Okay, now this guy is not redundant. Now this guy is saying that this is not the product of two ints, it's the product of two reals, because the return type must be real. Okay, so sometimes you can have that, you can have redundant type information, you just can't have conflicting type information. This one's not redundant right now, because if I remove it, that changes the function. Now it's a function that takes in two ints and returns an int. Now it's a function that takes in two reals and returns a real. Okay, all right. Okay. Now I could also do it over here. Oh, we didn't do that over here. We didn't. It's also possible to do your type declaring on the right-hand side. This is now you can't do this in Java. So here's something that ML can do that Java can't. This takes in two things. Two things. What are they? Well, they're the product. I'm going to take the product of two things. I don't know what this guy is, but here I'm saying, oh, X is a real. That's the same thing as if I said it over here. It's really the same. I could say it over here, or I could say it over here. But now I've said that X is a real. Well, if X is a real, this is the product of two reals, so Y is a real, and the return type is real. So I could put the declaration over here instead of putting it over here. So this is the same thing as that. ML lets you, it's quirky, they let you do the type declaration on the right-hand side if you want. Okay, this is not a type declaration. This is a type declaration. What is this? What is real of X? Or what did we say it was over here? What's the difference between that and that? This guy here is a what?
Genetic cast or
No.
no promotion.
No. There is no cast and promotion in ML. So what was it? We said, what was it? There's no cast and no promotion in ML. So it's a
Function.
That takes in an int and gives you back a real. So it's a function. Okay, so this is a function that takes in an int. So X is an int. But this function returns a real. So this is the product of what? Two reals. So Y is a real. So this function takes an int and a real. Okay, this function took in two reals because of that declaration. That's not a cast, that's not a function, that's a declaration, type declaration. This is a function whose, now here I could put the declaration if I want, but that's what real takes in. Real takes in an int, so that's redundant. The real function takes in an integer variable, so that declaration is redundant. So I don't need it there. So I'll go ahead and drop it. Okay. Real takes in an int, so x is an int. Real returns a real, so that means this is the product of two reals. So this guy's a real, so that guy's a real. And the function returns a real, okay? What's this guy do? Is it the same as this one? How are F5 and F6 similar, and how are they different?
They both return a real, but in F5, X would be an integer that's when
Okay, they
you.
both return. Okay, this is an integer.
Yeah,
What about F6?
it's real
X is a real, and Y is a
integer.
yeah. So this is int real, and this is real int, and they both return a real. Okay, so this goes an integer and a real versus a real and an integer. And again, real of Y means that Y must be an integer. So Y is an integer. But that means that this is a real, so that means this is the product of two reals. So this guy must be a real. Type inference. This kind of thinking is not dumb. This kind of thinking is what you're going to be hitting your head against when you start doing more sophisticated programming, and even in Java. In a little while, we'll go and look at how Java does things similar to this. When you start doing generics, this stuff becomes important in Java when you start programming in generics. One of the things I like to keep pointing out in these classes, the guy who wrote Java generics is one of the guys who invented ML. Okay, that's an important thing to kind of get as a hint of where the direction of Java is. If you want to know what the future of Java is, the guy who put generics in Java was the same man who helped invent ML and Haskell. They went to him to help the Java people went to him when they needed help developing their language. Java didn't get generics until like 15 years after the language was invented. Generics were added to Java way after the language was invented. ML was invented way before Java was, and ML has a sophisticated type system. Java generics is based on ML's sophisticated type system. And in fact, it was the same person. If you, let's see if I get the book. There's a book called Java Generics. Oh yeah, there it is. There's the book. This guy here, Philip Wadler, brilliant, really brilliant theoretical computer scientist. He wrote the Java generics. After he wrote the compiler for Java generics, and then he wrote this book about it. He's also one of the persons who wrote the ML and Haskell compilers. Okay, he's a very, very brilliant theoretical computer scientist who works on all this type theory stuff and helped invent these ideas. And the Java people turned to him when they needed to add generics to the Java language. Now, the C++ people also added generics to their language in a completely different way. So they did it in a way that was not as influenced by ML. C++ has generics in a very different way than Java has generics. So Java's generics are more influenced by these ideas than C++ is. But this reasoning we're doing here is important. You have to start learning to read type information and think about type information and think of type inference. going from a little bit of type information to more type information. It's a way of thinking that's going to be useful. Yeah, and it's a way of thinking it's growing and growing and growing. The effect of ML was invented actually in the 70s. And it's only been in the last 10 years that the programming world has realized that the ML people were onto something, that they were doing things actually right. So now languages like Java, JavaScript, C++ are backtracking and putting into their language a lot of the ideas that came out of ML and Haskell. They're literally backtracking to the 70s and the 80s and going, what were these guys doing in the 80s? Let's do it now. So Java's got generics, and Java has type inference, and Java still doesn't have tuples. One of the problems is tuples don't exist in Java. The Rust people whole hog agreed with a lot of what ML does. Rust has type inference. Rust has tuples. Rust has a lot of the ideas from ML in it. Okay, so these little puzzles, when we read these things and we think about what, when we puzzle through what these things do, it's a good way to think. It's a good way. It's a good thing to know as a modern programmer, because especially you guys are young, you're going to be programming for 20 or 30 more years. 20 or 30 years from now, this stuff will be ubiquitous. Every programming language will have tuples. Every programming language will have type inference. Everything that's in ML will be in every programming language 20 or 30 years from now. Okay, yeah, and probably by then Java and C++ will become maybe obsolete by then. But we're now in a transition phase. We're ending the era of the way Java and C++ were invented, and we're entering an era of this kind of stuff. This is going to be the future of programming. Okay, all right. So we'll keep doing. Now, this is what we're going to do with types. Notice we've been talking about types all day. We weren't talking about what was in language in chapter 6. We were, but we're really talking about how does ML read this type declarations? How does ML play with type declarations? Okay, so we'll keep doing examples like this, and then we're going to look at. Then we're going to start. Well, we're going to start chapter 7, which is more about ML. We're going to look at how this stuff can be used to. We're going to do something called pattern matching. Pattern matching is an interesting. It's a feature. It's another idea that Java doesn't have, that ML has, that JavaScript now has it. Rust now has it. Pattern matching is a brilliant idea, and it's moved from ML to JavaScript, and it's moved from ML to Rust, not to Java. So we're going to mix functions and types and something called patterns. Patterns are really interesting. Patterns are really another brilliant idea of the ML people were patterns. Okay, so that's what we'll start with on Thursday. Start reading the beginning of chapter 7 on patterns, and we'll keep playing these little it's more puzzles. We're going to keep reading this code and trying to we're going to keep reading little snippets of code and try to parse what it says. Get used to reading little snippets of code and thinking real hard exactly what does the little snippet of code say. Okay, so we'll quit there, and we'll start talking about patterns on Thursday. Okay, so I'll stop sharing, and we'll meet again on Thursday then. Okay, bye.